Today's problem was submitted by a viewer, and it says, given that A is positive and B is positive, prove that A over B plus B over A is greater than or equal to 2. So we want to prove A over B plus B over A is greater than or equal to 2. Okay. I'm not sure exactly what my approach here will be, but given that we're adding a number and it's reciprocal, obviously one of these numbers has to be greater than or equal to 1. In fact, it doesn't really matter that we have two variables here. Let's just call this x plus 1 over x. And any values of a and b we put in here, this is going to be, let's just call that x, and then this has to be 1 over x. Of course, x is still positive here, but for any value of a and b that we choose, there will be some value of x and the corresponding value of 1 over x. And similarly, for any value of x I choose here, there are values of a and b that correspond to this expression. I mean, there's an infinite number of values. For any one value of x, there's an infinite number of values of a and b, but that doesn't really matter. So let's just call this f of x, and I'm going to go ahead and maximize. Sorry, not maximize. I want to minimize f of x. Right? Because I want to show that for any value of x I put in here, we always get something greater than or equal to 2. So I'll use, maybe there's better ways of doing this, but I'm just going to take a derivative and set it equal to 0. So this, of course, says that x is equal to 1. F of 1 is equal to 2. And so this means f of x is greater than or equal to 2 for all x. And that's it, really. Yeah, my first instinct wasn't to do that, wasn't to just replace this with an x. I thought maybe some rearranging of this, multiplying through by a times b or something like that. In fact, that might even work. That might even work if I take something like, so if I take a over b plus b over a greater than or equal to 2, if I multiply through by ab, this gives me a squared plus b squared greater than or equal to 2ab. So we're trying to prove the equivalent to this. And isn't this, I mean, I don't want to simply quote another result, but this looks like if I let a squared be, let's call that, I mean, I'm reusing x here, but this looks like x plus y over 2 greater than or equal to root xy, which is, the fact that the arithmetic mean is always greater than or equal to the geometric mean. Which, I mean, is this the standard way of proving it? I don't know what the standard way of proving that result is, but if you can assume the well-known result that the arithmetic mean is greater than the geometric mean, then just reverse these steps. And we didn't do any operations that are irreversible. There's no multiplication by 0 or anything like that. We didn't square anything. So this implies that. I wonder if there's another Maybe there's another way of seeing this, but I'm happy with my first approach here. We minimized this function. This is always greater than or equal to 2. So the original expression is also true. Thanks for the submission, and thanks for watching.